Unleashing the power of AMD Zen, a 4x performance boost with a simple code change. Imagine quadrupling your computing power with a single tweak. That's the magic AMD Zen users are experiencing thanks to a recent update to the GNU C Library, Glibc. But here's where it gets controversial. The change involves dropping a specific implementation, and the reasons might surprise you. The Glibc code, an essential component for many systems, has undergone a transformation. By removing the LDBL 96 FMA implementation, developers discovered a remarkable 4x improvement in throughput and latency on AMD Zen 3 hardware. It's like upgrading your car's engine without even changing the oil. The long double implementation, with its 96-bit precision, was replaced by the more efficient 64-bit double FMA. And the results speak for themselves. On recent x86 hardware, the LDBL 64 implementation leaves its predecessor in the dust. In x86-64 benchmarks, AMD Zen 3 saw a whopping 4.06x increase in throughput and a 4.00x improvement in latency. Even in i6-86 mode, the gains were substantial at around 2.2-2.3x. The change was implemented through this commit, https://sourceware.org/git/p=glibc.git. A equals commit. H equals 4207844FF1BD5343786013272467414. Now part of the Glibc Git repository. This update will be officially released with Glibc 2.43 in February, bringing with it not only this performance boost, but also detection for newer CPUs, the MSEAL function, and other optimizations. And this is the part most people miss: the impact of such a simple change. It's a reminder that sometimes less is more. By dropping the LDBL 96 FMA, Glibc has streamlined its operations, resulting in a significant performance enhancement. But what do you think? Is this a bold move or a risky one? Could there be hidden drawbacks? Share your thoughts in the comments. We'd love to hear your perspective on this intriguing development.